on the next page, we're going to have, and I'll zoom out here to just so you can see a little bit of the page in its entirety, is a gigantic summary of what this entire process that we just went through kind of contains. This page can look very overwhelming at the start, but I assure you it's actually extremely simple because we already did all of these particular steps. I'm going to talk through each of these slowly before we jump into a specific example. And I'll show you how all of these steps here relate to some of the stuff that we'll actually see on the formula sheet. So if you have that out, be ready to take a look at that. Okay, so one of the first things we do in this process of hypothesis testing is we, well, write some hypotheses. And we'll see that our hypotheses kind of always come in, well, pairs, right? I always have an H0 and I always have an H1. H0 pretty much always looks the same. I'm either going to have that, say, a value of P is equal to some number. Notice here that P0 is just some number. So this statement over here could say like P is equal to 50% and P is less than 50%. Okay? The number that's in both hypotheses is always the same. It's very nice. Now you'll notice that as I move to the second set of green boxes, the only thing that's different is I might have a different H1. Maybe I'll claim that P is 50% or P is greater than 50%. Or in the very last case, maybe I'll claim P is equal to 50% or P is not the same as 50%. It's just something else, but I'm not sure if it's bigger or smaller. And this kind of creates a couple different types of what we would call tests. You'll see that when I deal with this less than sign in the first case, I create a left-tailed test. When I'm interested in something being greater, I get a right-tailed test. And when I'm interested in something not being equal, I get a two-tailed test. And we'll take a look at each of these instances and some of the examples to come. We'll see that there tends to be a distinction between what happens with the left and right tail tests versus what happens with the two-tailed test. Okay. But essentially, step one is write your hypotheses. Step two is always going to be like, look at what we call the test statistic. Essentially, look at the evidence. Look at your sample data and see what you find. So oftentimes what we'll do is we'll list out the sample evidence. Like in this case, we needed to know like X, how many people said they were going to vote for the candidate? N, how many people were there in the sample? And P hat, what's that percentage of people that were going to vote? We checked appropriate conditions. We also computed what we called a z-score. In this case, we'll also refer to it as a test statistic. It's a z-score for the sample result. We then had to kind of analyze under the assumption that H0 was true. We kind of tried on the hypothesis of H0 to see if it fit. And we did some stuff where we like drew out a picture, we shaded some things, we labeled some stuff, we got a probability back. And what we'll see here is that there are actually some ways we're going to be able to automate that using some new calculator commands that I'll talk about momentarily. Okay? And at the end, we ultimately had to state a conclusion. Ultimately here, you can focus on just the stuff in all caps for the moment. Our conclusions were either to reject H0. Remember, that means that we were going to pick H1, or not reject H0, which meant that we were going to stick with H0. It's important to realize that H0 is already being tried on. So we can't say whether or not H0 at the end of the day is correct or incorrect, whether we think it's, or whether we have evidence to support it or not. It's just that, you know, we tried it on and it seems like it fits okay. So I'm going to write conclusions then in this context. If I reject H0 and say I'm going to pick H1, I'll be able to say something like there's significant evidence to conclude whatever H1 says. I found enough evidence to get rid of H0. But if there's not enough evidence to get rid of H0, that's just exactly what I say. There's not enough evidence to conclude whatever H1 says. Like I'm going to stick with H0. This last point down here is important. We never are going to say that we accept H0 because can never find evidence that H0 is true, only that we don't have evidence to say that it's guilty or that it's not. So we have that kind of awkward verbiage being used there. Now, again, this page can be slightly overwhelming and there's a lot of information here, but this is where I'll point you to take a look at the formula sheet. On the formula sheet, I'd like you to go ahead and do a couple different things. First, I'd like you to go right here, right below the word conditions, and draw a nice big line all the way across your formula sheet. If you don't have a formula sheet, you can take a look at ones that are posted up in Blackboard. Okay. What you'll see is that I've kind of divided this page now into like 4 different boxes. You'll notice that on the left side, I'm dealing specifically with things related to P. And on the other side, I'm going to be dealing in later sections with things related to mu, to averages. So this is section 7.1 here, where we're talking about how to conduct a hypothesis test. And you'll notice that I list down here all the checks that you'll need to run. I write down here that you're going to be getting a z-score for a normal distribution, and these are all the numbers that the calculator will need in order to be able to compute that value. So this is going to tell you what numbers you need to look for in the problem. And this here is a new calculator command I'll show you how to use, where you can type in all these values and have the calculator do all the work for you almost immediately. Okay, so we're going to practice with 7.1, and in a later video, we'll take a look at this other box in 7.2. We'll see some similarities and some differences. Okay. We'll end this video here, and in the next video, we'll start to take a look at some of the examples.